Alright, let's do an example of trig substitution. Now, here's the example we have here is a pretty simple one. Find the integral of x over radical x squared minus 9 using trig substitution. If you're observant, you'll notice that this actually can be pretty easily done with u substitution, but that's just the nature of these simple examples, I guess. But we'll use trig sub anyway for the sake of the example, even though u sub would probably be the better way in general to do it. So if you're familiar with the rules of trig sub, then it should jump out at you the fact that at the bottom here, we have a radical x squared minus 9. And 9 is the same thing as 3 squared. So we have x squared minus a constant squared, or a squared, which, with the rules of trig sub, that's going to be related to secant. So we know that x would be equal to a times secant of theta on the bounds of 0 is less than or equal to theta, which is less than pi over 2. Now, let's sub in our actual values here. So, like, what we actually have given is x squared minus 9, and 9, the square root of that is 3. So it's x squared minus 3 squared, really. So our x, our true value for x, is going to be 3 secant of theta on the boundaries I previously mentioned. That's an important thing to specify. So we'll also have to make note of our dx, since that's pretty important as well. So dx is equal to 3 times, and then the derivative of secant of theta is equal to secant of theta times tangent of theta. So dx is going to be equal to 3 times secant theta, tan theta, d theta. There we go. Now, to actually make use of this, now we got to rewrite our initial integral that we're given in order to actually take advantage of the substitution we're going to make. So this is going to be equal to, and then, so let's substitute out our dx for this. So at the top then we're actually going to have 3 secant theta tangent theta d theta, and that's going to be over square root of x squared minus 9. So let's change that to where instead of x squared, instead it's 3 times secant theta, which squared is going to be 9 times secant squared of theta minus 9. Now, when we have it written like this, I'm just going to go to the side here so we don't have to rewrite all of this 7 times over. But with just what we have in the radical alone, we can rewrite that to take out the 9 there. Take out the 9 and distribute it. Or undistribute it, I guess. So we can have it written as 9 times secant theta minus 1, or secant squared theta minus 1, which is equal, it's the same thing as, if you know your identities, that's the same as 9 times tangent squared of theta. Or you can rewrite that whole thing as, if you want to write it, this whole thing is in a square, to get it as 3 times tangent theta squared, which this square, see, I took the whole thing and took out the squares that's on the outside. So instead of 9 or 3 squared times tangent theta squared, now it's 3 times tangent theta under all square. And the reason why I'm doing all of this, the reason why I'm doing any of this to begin with, is because now that I've done it, now this whole thing can be put in a much simpler form, where I've got this whole thing squared, and it's under a radical. Meaning, when it's under the radical, the whole thing just becomes regular 3 times tangent theta. So if we were to simplify this further, this whole thing becomes the integral of, and then it's the same numerator, secant theta times tangent theta d theta, all over, and then it's just 3 times tangent theta, because the square is undone by the radical up there. So over 3 times tangent theta. And now that we've got it in this easier form, where now there's no more radical to deal with, now we can sub out some values to make this much simpler to work with. And And also, let's not make the mistake I just made, because also, not only is there the dx sub out, but there's also the x right there. There's also the x right there, which is going to be equal to 3 secant theta. So let's also multiply it by this top bit here, and have the 3 times secant theta at the top. So you got that as well, and also the d theta there. That's important to remember. But now that we have it in this form, now we can cancel out some of the numbers that we do have. So this 3 can be canceled out. This tangent can be canceled out because we don't need that. So the whole thing now simplifies down to just 3 times secant times another secant. So 3 secant squared theta plus with the d theta. And you know what? I'm actually going to write this in a way so the 3 is on the outside. Right there. Yeah. So now we have it like this. And once again, if you're familiar with identities, this is going to help out a lot. Or if you're just familiar with basic derivatives and basic antiderivatives. Because if you'll remember, the antiderivative of secant squared of theta is tangent of theta. Because if you'll recall, you take the derivative of tangent in order to get secant squared. So this is going to be equal to 3 times tangent of theta plus c. And that is an integral, but we want this in terms of x, because the original integral asked us to find it to integrate with respect to x. So let's change this about. So once again, we'll have to go back to using our little triangles. So let's draw a lovely little triangle right here with our information. So you got the nice little theta there. And with what we have up here, where x is equal to 3 times secant, so let's write that down. X is equal to 3 times secant theta. Let's get this into a fractional form. So that becomes x over 3 is equal to secant theta, which, as you know, since secant is the reverse of cosine is adjacent over hypotenuse. But since this is the flip of that, the reverse of that, it's going to be hypotenuse over adjacent. So x is going to go into the hypotenuse, 3 is going to go into the adjacent side, and the opposite is going to be what's left. That's going to be the radical x squared minus 9. So if we have it as tangent, so if our answer is tangent theta, we're going to want to take the tangent of that theta. So of theta, tangent is opposite over adjacent, so that's going to be the opposite side, or the radical x squared minus 9 over 3. So our integral then is going to be equal to 3 times radical x squared minus 9 over 3 plus c. But then 3's cancel out, so then our integral just becomes radical x squared minus 9 plus c. And there you go.